Now that we've seen how satellites collect their data, we're going to look at how they transmit information back to Earth as we learn about analog and digital signals. You probably know that satellites rely on digital signals to transmit and store data. But what exactly does digital mean? Because digital is everywhere, it makes sense that the state of California wanted us to include the idea of digital in our teaching, but it's pretty new to a lot of people. So let me walk you through a little bit about digital and the alternative to digital, analog. Let's say we're looking at two different types of thermometers that you might find inside your house, an analog one with a dial like this, or a digital one. Now, which one's easier for you to read? Well, clearly the digital signal can be seen far across the room. It's very clear what the temperature is, but can you tell from the digital signal that the temperature is actually a little bit higher than 71 and between 71 and 72? Well, sure, you could add another decimal place to the digital readout, but then would it be able to tell the difference between 71.11 and 71.12? With digital, you have to stop at some point, but analog shows you an infinite level of precision. So which one's better? Well, there's a trade-off when it comes to precision. When it's trying to transmit that information, it turns out that you can encode information in waves using either analog or digital. When you're making an analog signal, you change the frequency or amplitude to represent a number. With digital, you transmit the number as binary, on and off. A good way to think about this is that analog is like a dimmer switch that you turn up and down, while digital is like a light switch that you just flip back and forth over and over again. The challenge comes, though, when you try to decode that signal reliably. With analog, it can be difficult to distinguish between the encoded information and background noise. With digital, though, you just have to detect whether the signal is on or off. And you can think about this like, if I'm talking in a crowded room, sometimes you can't make out all my words, yet you are able to hear whether I am talking or not at any moment in time. And that makes digital so much more reliable, which is why we use it almost exclusively in our communications today. Now, digital does come with a little bit of a cost. Let's imagine we have a satellite that's trying to take a picture of a river that has bends and curves, and we want to send that information back down below. One way we could do that is using an analog image. Basically, we'd capture the shape perfectly by varying the frequency and the amplitude of the wave. But we know we want to send it by a reliable digital signal, so we start collecting a few coordinates and converting those to numbers that we can send over binary. But in this particular case, we took too few coordinates to really capture the true shape. And this happens often in digital. So we could just collect more and more coordinates, but as we do, it means that we take longer to transmit the information, and it takes up more storage on the other side. And even with all that done, it still doesn't look as good as the analog signal. Of course, speaking of storage, there's simply no way to store this analog image at all. I mean, we could take a photo, but unless you want to use old-fashioned film, you'll have to take a digital photo with a fixed number of pixels, and now you're back to all the drawbacks of digital. So if we want to summarize, analog gets us this infinite precision, while digital does leave out some of the details. But analog is disrupted by noise, whereas digital can be reliably decoded, and it's easy to store. These two things together tend to win out, which is why you're listening to me now digitally instead of on an old Victrola. To introduce these ideas to students in Lesson 18 and get them to answer the question, what's the difference between analog and digital, we start off by showing students two different devices, one analog and one digital, and getting them to notice some of the differences between them. We use that to start a working definition of what analog and digital are that we're going to be developing over the next few lessons. The challenge for students in this lesson is to encode and transmit data in an analog form. We're going to ask students to measure something's weight, its size, its brightness, without using a measuring device like a ruler or a thermometer or something like that. And then they have to communicate the information across the room to another student. So a student might say, I have an object that's bigger than my shoe, but smaller than the desk. They're able to use these milestones to define the size of something in a similar way that you might use the tick marks on an analog device to get an actual measurement out. They'll reflect on this experience in their worksheet and then go do some reading about analog and digital, describing the characteristics of each of those approaches and some examples from each. Then they'll start thinking about making a claim about which is more reliable, analog or digital, and they're going to be building that up also over the next few days. In Part 2 from Lesson 19, students are starting to think about which is better for sharing information, analog or digital. Students visit 4 different stations, one for photography, one for measuring temperature, time, and weight. And at each station, there's 2 different devices, an analog one and a digital one. There's a different scenario at each station. For example, let's say you're sending a birthday gift to your friend on the other side of the country and you need to know the weight of the item. Which scale is most effective, an analog or a digital one? And then how would you share the data from each of those? In the end, we debrief and we ask our students to identify patterns in these technologies. In Part 3, Lesson 20, we really address the question of which is more reliable, analog or digital. We start with a warm-up, a think, pair, share, to discuss some of the pros and cons of analog and digital from yesterday. Then we show students a brief video that discusses how noise can affect the reliability of transmission of analog and digital signals, which will really illustrate to them some of the advantages of digital communication. But then we'll also introduce them to some of the limitations of digital, as we try and take an analog signal and convert it into digital, taking a certain number of samples as we take coordinates off of a graph to map a river. And now that students have really dug in to figure out what analog and digital are, they're ready to construct a claim about which one they think is better for transferring information. They're going to back up their claim with evidence and reasoning, and we've got a rubric to guide you and the students through that process. Next up, students use coding to show what they know about satellites.